Hello everyone, my name is Prithviraj. I am starting a new video series in which I am going to teach you the assembly language program for ARM7. To write the assembly language program for ARM7, we are going to use the keil software. This is how the keil software looks. In this video, I have not shown the installation of Keil Vision 4 software. If you want the video on it, then do leave the comment in the comment section. I will definitely make a video on it. Now we will see how to work with the Keil Vision 4 software, and I will also give you an example of assembly language program. First we will make a new folder over here called as ALP for ARM7. After making an folder, I will double click on this keil software. This is how it looks. After coming over to this window, you should click on project and click on new project and go to desktop and select the folder which you have created, and there give some name like source, source, and save it. Here it will ask for the microcontrollers. Here we are selecting ARM. In ARM we are selecting ARM7 Little Indian and click on OK. Here the target is being created. You can click on this plus symbol and see the source group. Now I will create a new file over here by clicking on this new file or directly on Ctrl N. I will enlarge the text area by clicking on Ctrl and scrolling the mouse roller. Now we will write the assembly language program for addition of two numbers. In ALP program, for comments we use colon like this. I will write here addition of two number. You should remember that your caps lock should be on. Here we will define our code. As the general syntax, we will write AREA area. After space, we will write the file name. File name may be capital or small. I will write ADD1, and rest of the things should be in capital. That is, we will define that this area is code area, CODE, and it is of the type read only, READONLY. And here we will write entry, ENTRY and end. This is the general syntax of writing an assembly language program in Keil software. So this is an entry part of the program, this is an end part of the program. In between this, we will write our assembly language program. Now I will write the addition of two numbers using move instruction. This move instruction will transfer the immediate value, that is 1 in R1 and 2 in R2. I have transferred 1 in R1 and 2 in R2. Now I am going to add them. ADD R3, R1, R2. R3 is the destination. R2 and R1 are the source. These two get added and is stored in R3. For move instruction, immediate value is given by hash, this one. This may be a decimal number or a hexadecimal number. This is the example for decimal number. We will also see how we can give the immediate value as a hexadecimal number. I am going to save this on clicking on Ctrl S, and I am going to save it as addition, ADDI in small letters, ADDITION .s. The extension should be .s for writing an assembly language program, and I am going to save it. Now you can see the color of this has been changed. As the file has been saved, now we should include this file to the source group. Right click on the source group and click on add existing file to a group. Here you can see there is a .c. This one we should change it to .es. Our file which we have saved will appear over here. Click on it and click on add and close. Here when you click on the plus symbol, you can see that the file has been added. Now we are going to compile this. Compilation is done like here, that is called as rebuild. I am going to compile this. Here you can see it says 0 error and 0 warning. Now our program has been ready. Now we will execute it. Like we will see how the content are stored in the register. For that you should click on this debug and start or stop debug session. Click on OK. And I am going to adjust this window over like here. Here you can see all the registers up to R7 and CPSR and SPSR which are there in ARM. Now I am going to execute step by step. Here you can see this cursor has been pointing to the first instruction of move. For step by step execution you should press F11, or for the complete once execution you should press F5. I am going to press F11 for step by step execution. F11. Here you can see the first instruction has been executed and it is showing in green, and the value of 1 is stored in R1. I am press one more time F11. The 2 has been stored in R2. The addition of this 3 will be stored in R3. And one more time press F11. The value has been stored. Now after pressing F11 again and again, you will see an error over here like saying that access violation. This usually happens when we code an assembly language program. Now we should go on this again debug session and stop it to come back to our original file. Now I will give a little bigger number like 100 and 200. I am going to save it and compile it or rebuild it. 0 errors and 0 warnings. Now I am going to start the debug session. Okay. Here the number is in decimal. This number is going to be converted into hexadecimal equivalent, that is 64, and that is going to be stored in R1. This one is converted into C8, that is hexadecimal equivalent of 200, and that is going to be stored in R2. I press F11, 64, again F11, C8 is stored, and I will press one more time F11, and now we can see that the total 300 is converted into hexa and stored it as 12C. This is how the decimal value works. Now we will see the same thing using the hexadecimal value. Click on here and click on stop debug session. Now here I am going to give the hexadecimal values, that is 0, X, and one thing you have to remember, that is this is 32 bit. The 32 bits are divided into 4 bit each. Like for example, I will give an hexa value over here 00000000A, capital A, and this X should be also capital. Okay, that is this is 8 numbers. Each number over here is of 4 bit. 4 into 8 will give you 32 bit. In hexa the maximum value is 15. That is represented by 4 bit. That's how each bit is 4 bit over here. Here I am going to give the other hexa value like 00000000B. A means the 10 in hexa, B means 11 in hexa. Okay. Now I am going to save it by pressing Ctrl and S. I am going to rebuild it. 0 errors and 0 warnings. Start debug session. You can directly click on Ctrl and F5 and click on OK or enter. When I am going to press F11, you can see that the hexa value of this has been stored in R1, and again the F11 B is stored. Now the addition is done and the value is stored as 15, that is the hexadecimal of the 10 plus 11. For stopping this, you press on Ctrl and F5. So this is it. In this video, we have seen how to start writing with an assembly language program, and we have also seen the two instruction move, add, and also the syntax of assembly language program. In next video, I am going to deal with the new programs and new instructions, and I have also not dealt with the limitations of move instruction and the errors which we get on making a slight change in the program, which will also be covered in the next video. This is it. I will see you in next video. Bye.